We are asked here to determine whether the lines described are parallel, perpendicular, or neither with one another. So of course, when lines are parallel with one another, as long as they are not the same line as each other, and then they have the same exact slope as one another, that's how we'll be able to tell if lines are parallel with one another. Now, kind of jumping to the neither case, there's a couple things that could happen right there. So neither parallel nor perpendicular means not going the same direction as each other, not at 90 degrees. So there's a couple things that could fit into that category. One is just the lines cross, but not at a 90-degree angle. And the other case could be that you have a line, but then you also have another line where they're right on top of each other. So in that particular case, we actually call those lines coinciding with one another, or that they coincide. And that's kind of a special case. We'll get into the nitty-gritty details of a little bit later on, but I just want to at least introduce that idea. Otherwise, right here, we can just call these lines here just intersecting whenever they have different slopes. Now, understand that if lines are perpendicular, they also are intersecting, okay? But it's just a little bit more particular because when you have the slopes, it turns out that the product of the slopes is going to equal -1 as long as they're diagonal lines, which means that you're really going to have opposite reciprocal slopes with one another. So with line 1 and line 2 here in the first example, you can see that we just have ordered pairs that the lines are crossing through, so we can just compute the slope. So if we do y minus y, -1 minus +2, and then do x minus x, which would be 0 minus -2, we end up getting -3 over +2 for the slope of line 1. And then for line 2 there, if we do y minus y, we have 3 minus -1. And then x minus x would be 2 minus -4, which is going to give you +4 over 6. That does reduce down to 2/3, I guess. And so then if you compare those two slopes, you can see they are reciprocals, and also one's negative and one is positive. So therefore, you do have opposite reciprocal slopes. So we're able to conclude then that indeed these lines are going to be perpendicular because the lines have opposite reciprocal slopes. And then if we move over to line M and line N and we find the slopes there, you're going to have a -6 minus -1 for the change in the y's, and then a 1 minus a +4. So you end up getting -5 over -3, which gives you a positive 5/3 slope because it's a negative divided by a negative. And then for the other line, line N, if you do 6 minus 1 for the change in y's, and then -1 minus +2 for the change in x's, you get +5 over -3, which is going to be -5/3, of course, for a slope. So you can see that these slopes right here are not the same because you got a +5/3 and a -5/3. So definitely they're not parallel to each other. And also, they're not opposite reciprocals because they both have 5 on top and 3 on bottom. They are opposite in nature, but ultimately, really, the lines are just going to kind of look like this. One has a -5/3 slope, and the other has a 5/3 slope. So they're just going to cross each other. So all that we can say right here is that they're going to be intersecting with each other. So based on how the question was wording, it just says determine if they're parallel, perpendicular, or neither. So if you're going with the question, it would be neither. But I think a better way to answer this is just to say like that M and N intersect because they have different slopes. At a non-right angle, which just basically means they intersect at some angle that's not 90 degrees.